Good day, my angels. So here is the solutions to lesson 6. Lesson 6, question number 1. Find the terminal voltage of a 6-volt cell with 0.6 internal resistance. I need to draw this. So here's my cell. This is 6 volts. There's an internal resistance of 0.6 ohms, and it's connected to a 7.2 ohm load. Find the terminal voltage. Okay. Step 1, the label down here. Step 2, find total current. Don't know it. You know what? I'm going to jump right to step 5, which is rewrite this. Our total, because those two resistors are in series, is going to be 7.8 ohms. I went 7.2 plus 0.6. So I total is going to be V over R total. It's going to be 6 divided by 7.8. Is 0.7692. So that means I have 0.7692 amps going through that 0.6 ohm resistor right there. So this is 0.7692 amps. So the terminal voltage is going to be 6 volts minus I times little r. It's going to be 6 volts minus 0.7692 times 0.6. 6 minus answer button times 0.6. And I get 5.54. Answer key says 5.53. Should be 5.54. I'll fix that. Volt. Now the other way I could have done that is I could have just figured out that voltage right there because it's the only external resistor. So I could have gone 0.7692 times 7.2, and I also get 5.54 volts because that's what's left over to power the actual circuit. So you can find the terminal voltage by going EMF minus what you lose going through the battery, or just by calculating what's left over for the battery. I'm going to fix that answer key right now. Question 2. Nope, question 3. I skipped number 2. Okay. Again, I'm probably going to quickly do a sketch. I'm going to do a rough sketch. In number 1, I did a good circuit diagram. Messy, but I did a proper one. Here, I'm just going to quickly crunch this. So let's see. We have a 1.5 volt cell. There's no other resistor, and we'd like to find little r right there. But we know that there is 30 amps going through it. Well, if the terminal voltage is 0, that means that we're losing 1.5 volts going through little r. So R must be V over I. I must be losing 1.5 volts divided by 30 amps. This is going to have an internal resistance of 0.05 ohms. Number 4. Similar question to number 3, except there's an external resistor as well. So if I do my really quick sketch, I've got my little internal resistor R. Here is my that's the terminal voltage, sorry. Here is my 12 volts. There's an external resistor right there. It's telling me that the terminal voltage is 8.8. If I'm starting with 12 take away 8.8 is, I must be losing 3.2 volts inside the battery. So this has to be 3.2 volts. And they told me that 0.7 amps are flowing through here. There you go. R is going to be V over I. It's going to be 3.2 over 0.7. I can tell you how big the internal resistor must be. 4.57 ohms. Did I do that right, Mr. Duick? Sorry, not 0.7 amps, 70 amps. Didn't even read the question right. How did I miss that? 70 amps. So it's going to be 3.2 divided by 70, which gives me 0.046 ohms, not 0.045. I'll fix that in the answer key as well. Number 7, hey, here's a picture I can draw on this or copy it or whatever. Find the total current in this circuit when switch A is A open and B closed. So when it's open, that means that this isn't even part of the circuit at all. That means that our total is 10 plus 0.5. The total resistance is 10.5 ohms. And so I total is going to be 20 divided by 10.5. And I get 1.9 amps. By the way, that also means that the terminal voltage would be 0.5 times, well, it would be I, answer button, times 0.5. That's what I lose going through there. So 20 minus that, this would have a terminal voltage of 19 volts. Let's compare that with B. Well, when we close this, now the 15 and the 10 are in parallel. So 1 over our parallel is 1 over 5 plus 1 over 10. And then take the reciprocal of that. 3.33333. And so that means that our total is going to be 3.3 ohms. I don't need to put the units. Plus 0.5. And I get 3.83. And so I total is going to be V 20 over 3.83. Did I read my own writing wrong? No, I didn't. 1 over 5 plus 1 over 10, and then reciprocal. Yeah, this works. Let me pause for a second. Sorry, having a brain cramp there, but I'm back. 20 divided by answer button, and I get 5.2 amps. So we're using way more current. By the way, the terminal voltage has also gone way down, because now if I go I times little r, that's how many volts I'm losing going through the battery. So the terminal voltage, instead of 19 volts, is 17.4. Number 8. Very, very similar question. So when we're open, our total is just going to be 10 plus 5.5 is 10.5. In fact, it's the same numbers as before. I total is going to be 20 divided by 10.5, which was 1.9 amps from the previous question. I remember that answer. B. B. Well, this is a problem. I shouldn't have really assigned number 8 because I haven't talked about this. You'll notice how this has no resistor. Basically, this is going to cause a short circuit, and all of the current is just going to follow this path, because electricity will follow the path of least resistance when it can. We're short-circuiting the battery, bypassing this resistor. And so what that means is our total is just 0.5 ohms. And so I total is going to be 20 divided by 0.5, which is going to give me 40 amps. And that's going to do two things. It's going to drain this battery really quickly, because remember, current is the amount of charges per second. So it's how fast you're draining the battery. And it's probably going to heat up the wire, because this wire might not be equipped to handle 40 amps going through it. And so remember, heat's generated by these electrons. We're pretending it's the protons move, because current is which way the protons would move if they could. But heat's going to be generated as these particles are moving through the wire. So you could heat up this wire, and fire is bad. But I shouldn't have assigned number 8. I haven't talked about that. My mistake. Ooh, number 9 looks cool. I love solving circuits. It says find R total, find everything. Okay, these two are in parallel, these two are in parallel. So over here, I'm going to go 1 over R parallel is 1 over 30 plus 1 over 15. R parallel for that guy is 30 reciprocal plus 15 reciprocal, 10 ohms. And here, 1 over R parallel is 1 over 40 plus 1 over 120. That's terribly messy. 40 reciprocal plus 120 reciprocal, 30 ohms. Okay, so this can be redrawn as a 100 volt battery. That top resistor is 10 ohms. This whole mess is 10 ohms. And this whole mess is 30 ohms. There's the mathematical equivalent. And so I can tell you that our total is 10 plus 10 plus 30, 50 ohms. I total is going to be 100 divided by 50. Hey, I can do that in my head. 2 amps. I'll put a box around those because the question did say find R total and I total. So that means there's 2 amps going through here. Two amps going through here. 2 amps going through here. That means in this path we lose 20 volts. In this path we lose 20 volts. And in this path we lose 60 volts. So up here, this has to be 20 volts. This has to be 20 volts. This has to be 20 volts. This has to be 60 volts. This has to be 60 volts. And now I know two things. Well, I already know 2 amps is going through there. Down here, if I go V over R, here is 0.5 amps. And that must mean that this is 1.5 amps. And if you went 60 divided by 40, you would notice that. Here, I can go V over R. It's going to be 20 divided by 15, which is 1.3 amps repeating, which leaves 2 minus that, or 0.6 repeating. And you would also get the same thing if you went V over R. So found everything. Then I could have found power in each resistor, but I didn't ask for that. So, okay. Number 10. You know what? The fact that they told me 2 amps goes through the 15, I might not need to rewrite this. Let's see. So I know that 2 amps goes through here, which means this is going to be 30 volts, which means this is going to be 30 volts, which means this is going to be 3 amps, which means I must have had 5 amps coming through there, which means if I go I times R, 5 times 14, this must be 70 volts. How does that help me? Let's see. Well, this whole path here is 70 plus 30 is 100 volts. So this whole path here has to be 100 volts. You know what? I am going to have to rewrite this just a little bit. I'll have to rewrite this as R parallel. So 1 over R parallel equals 1 over 4 plus 1 over 4. R parallel equals 4 reciprocal plus 4 reciprocal reciprocal. Oh, 2 ohms. So this whole path, if I do a really quick resketch, I have this. 5 ohms. This whole path here is 5 ohm because it's 3 plus 2. And I know that I have 100 volts going on this path. That must mean there's also 100 volts going on this path. Okay, now I'm good because I also figured out that this was 5 amps going along this path, and if I go V over R, this must be 20 amps going along that path, which means this must be 25 amps. And if I go I times R, this has got to be 125 volts. And so any one path, let's go this one, has to be V total is 125 plus 100. It's 225 volts. Ta-da! That's a pretty challenging question. Doable, but I would consider that one having some teeth. Number 11, the fact that they gave me 2 things, I think this question's going to fall apart. Let's see. I've been forgetting to label downhill, haven't I? Step 1, label downhill. Step 2, find total current. Hey, 3 amps. So that means there's 3 amps going through there. That means there's 3 amps going through there. That means there's 3 amps going through there. Step 3, I know 2 things. I could find R, but they didn't ask me to find R. You know what? I just need to find that. Well, I started with 12 volts. I lose 2 there. I lose 2 there. This has to be 6 volts. Otherwise, it doesn't have 12. Wow, that was way easier than number 10. Yes, that was kind of a cleanse the palate circuit. Because then we have number 13. Cool. Okay, so that's an internal resistor right there. They've drawn the little battery box or cell box to let me know that that's the power source. Very nice of them. This wants me to find the EMF of the battery. Okay, so I'm going to try and work my way backwards and figure out how big the battery has to be. I'm absolutely going to start right there because I know 2 things. Well, I guess I'm going to start by labeling downhill. Okay. I know two things. The voltage in the middle is I times R. So we have 7 volts here. That means this path is also 7 volts. That means that this path is also 7 volts. So I can figure out the current in each of those. 7 divided by 33, that's 0.21 repeating amps. 7 divided by 68, that's 0.10294 amps. So 0.14 plus that, plus the 0.14 amps plus that should give me total current. I'm actually going to do this by going 7 over 33 plus 7 over 68 plus 0.14, and that way I've got an exact value, and I get 0.4551 amps. So I have I total equals 0.4, what did I say? 551 amps, which means I have 0.4551 amps going through here, which means I lose I times R. R was 0.8, yes? 0.364 volts. I also have 0.4551 amps going through here, which means here I can go I times R. I can multiply by 10 in my head, 4.551 volts. So this, before I scroll down, this source voltage, this EMF, has to cancel out, or has to provide 0.4551 volts, 7 volts, and 0.364 volts. I'm reading the wrong number. Okay? This, let me say that again. This EMF is outputting that and those, but we only take one of them, and that voltage. So the EMF is going to be 4.551 plus 7 plus 0.364. 4.551 plus 7 plus, you know what, I'm going to use my answer button since I have it sitting there. And I get 11.9 volts. I think I forgot to include an answer for this one, didn't I? Then it wants me to determine the power. Power is easy, so that's A. B, power equals, let's go V times I, so it's going to be 0.364 times 0.4551, 0.364 times 0.4551, and I get 0.166 watts of power. Wow, I forgot to give you the answers for these ones. I added some questions and I forgot to add the answers. That was silly of me. What's the terminal voltage of the battery? Okay. I think I'm going to have to rewrite this. Okay, that's downhill. That's downhill. 1 over R parallel is 1 over 6 plus 1 over 6. R parallel equals, well, it's going to be 2 over 6, so 6 over 2, I think it's going to be 3 ohms. So I can redraw this as an 8 volt EMF, a 3 ohm resistor, a 2 ohm resistor, and a 0.7 ohm resistor. So our total is going to be 3 plus 2 plus 0.7. It's going to be 5.7 ohms. It's going to be, the terminal voltage is going to be the EMF minus what I lose, oh, I don't know total current yet, Mr. Dewick. Total current is going to be total voltage divided by total resistance. It's going to be 8 divided by 5.7, which is 1.403 amps. That's also how many amps are flowing through the internal resistor. So the terminal voltage is going to be 8, what I start with on the side of the battery, minus what I lose going through the battery, which is I times little r. It's going to be 8 minus 1.403 times 0.7. Why am I doing that when I can go answer button times 0.7? And I get a terminal voltage of 7.02 volts. Basically, we lose a volt going through the battery in this particular circuit. Number 15. Also didn't include an answer. Sheesh, Dewick. Find the value of resistor R2. Okay. Well, let's label downhill. They told me I total. This question's going to fall apart. Looks like I have 0.6 amps go through the bottom one. 2.4 minus 0.6 should be 1.8. That must mean I have 1.8 amps going through here. I know two things. If I go I times R, this is 9 volts. That means these two have to add to 9 volts. So 0.6 times 6, the first resistor is using up 3.6 volts. 9 minus 3.6, this must be using 5.4 volts. So R2 is going to be V 5.4 over I 0.6. R2 is going to be V over I, and it's going to be 9 ohms. That's for part A. For part B, well, I'm almost there. I can tell you that this has a voltage of I times R, 24 volts. And now if I ski, I use 9 volts plus 24 volts, and that gets me to the bottom. So the potential difference, the voltage, is going to be 9 plus 24, which is a 33 volt voltage source. $16. I didn't include answers for any of these. That was silly. What is the terminal voltage? Oh, it tells me the current. This question's going to fall apart. So downhill is this way. We have 1.8 amps, 1.8 amps. So for part A, I can do this two ways. I can go, that's also 1.8 amps. The terminal voltage, it's what's left over for the battery. So I think I'm going to say this. V terminal is going to be I. Well, you know what? Let's just calculate it on here. I times R, that first resistor, R1, is using up 4.5 volts. This second resistor, R2, is using 7.2 volts. So this battery is supplying 4.5 volts and 7.2 volts for a total of 11.6 volts. That's the terminal voltage. Now, what's the EMF? The EMF is going to be 11.6 plus the voltage that I lose going through the resistor. If I go I times R, I get 0.9 volts. That's what we're losing going through the internal resistor. So it's going to be plus 0.9. It's going to be 12.5 volts. Last one. Oh, they gave me two things. This question's going to fall apart because I know this is 0.4 amps, and since power equals V times I can tell you that V is going to be 3.5 divided by 0.4. Sorry, I said, yeah, power divided by I, 8.75 volts. They told me the EMF is 9 volts. I have 8.75 volts used up by this light bulb. That must mean that I'm losing 0.25 volts, and I already know that it's 0.4 amps, so little r is going to be V over I. It's going to be 0.25 divided by 0.4. It's going to be 0.25 divided by 0.4. It's going to be 0.625 ohms. Sorry I forgot to give you the answers for those last few questions. I apologize. I added them and I forgot to work them out ahead of time. Next week, you're going to get a take-home quiz. The week after that, we're going to write a short test, and I'll explain how that works when we get close.